Welcome to the JavaScript promise simplified. Well, in this short meetup, I'm going to try to simplify your understanding of the promise constructor function, of how to handle asynchronous functions, and the use of the async and the await keywords. Okay, then. So as of xtremejs 2015, ES6, we have the promise constructor function. And if you check the MDN, you will find that you can easily create a new object using the promise constructor function. You just need to pass over a function. And that function that you should pass over to the promise constructor function should be a function with two parameters. And those two parameters, when that function you passed over will be executed, two functions will be passed over to these two parameters. So that our code in our function that we passed over to the promise constructor function can call either the first function or the second. We will get back to it later. Now, the purpose of using promise is to simplify our code instead of having callback functions. Callback function is a function you pass over as an argument to another function, and you expect that callback function to be called, to be executed when a specific operation completes. For instance, maybe you are familiar with getting the location of your device. You call a function, you pass over a function, another function that will be invoked when the location is retrieved. And we use a callback function. We use this technique in order to call an asynchronous function. An asynchronous function is a function that when you call it, something starts working, but you don't wait till it completes its work. You don't wait for the response. Something starts working and our code continues. When that asynchronous operation completes, there is a need to pass over the result to specific code that we write so that our code will take the result and do something with it. So till xtremejs 2015, we used to do it using callback function. We called a function, we passed over another function, that other function was a callback function. So that when the asynchronous execution, calculation, computation completed, that callback function we passed over was simply invoked, and in many cases, the result was sent to that callback function. So when dealing with asynchronous execution, till xtremejs 2015, we used to do it using callback function. Using a promise is a way to make things simple. Using the async and await keywords, we can make things even simpler. Now, before getting into details, just want to remind you that we have a single thread. Yes, indeed, we can use Web Worker API to create new threads, but basically we have a single thread. And that single thread simply handles jobs one after the other. There is a queue of jobs the single thread handles. When the single thread that performs those jobs finish handling one job, it moves forward to the next one. And we call that queue or that loop the event loop. Whenever something happens, user press a button. If we are dealing with the front end, if we are dealing with the server side, suddenly a response came back from the database those are events that whenever they happen, a new job is added to the queue. And the single thread simply performs those jobs one after the other. Doing so, the computation is exploited successfully. So this is a model for exploiting the computation power we have instead of using threads. So we have only one thread, one queue of jobs. That single thread performs those jobs one after the other. And new jobs are added continuously. If we are dealing with the front end, then whenever a button is pressed, whenever the page is loaded, in all of these cases, a new job is added because a specific event took place and now a new job is added to the queue. If we are dealing with the server side, just imagine that suddenly a new request is coming from the client. So this is a new event, meaning a new job is added to the queue. And that queue holds lots of jobs. Each job is a collection of code that is executed without any pause, without any delays. So this way, the single thread that performs those jobs is always busy with something, or nearly always busy with something it needs to do to perform. There is no, the single thread is not paused because it needs to wait for something to happen. That doesn't happen. The single thread simply goes from one job to the other without any pause, without stopping. Now, as I told you before the possibility to use the promise constructor function, we were using callback functions. We still use callback functions, but not as in the past. And using a callback function might look like this. You call a function like func1, and func1 performs something asynchronously. And you don't know when that asynchronous execution will end, but you know that at some point it will end. And you want the result to be handed over to code that you wrote. So we can, in many cases, pass over a function. And when we pass over a function, we know that for sure that the function we pass over will be executed when the asynchronous operation completes. And the result of that asynchronous operation will be passed over to that function that we passed over. So this is the callback pattern. It is a well-known design pattern, not only in JavaScript. Now, the problem with this pattern is that when you have code with lots of callback functions, that code might look bad, we can say, we can summarize. It might become like L, too many callback functions, and it becomes impossible or nearly impossible to understand what exactly happens. And for that problem, we have promise. So the constructor function promise, and you can find detailed API documentation in the MDN website, for instance. The constructor function promise, when you instantiate and when you create a new object using this constructor function, you are expected to pass over a function. Let me move forward. Like in this case, as you can see, I create a new object using the promise constructor function. I'm expected to pass over a function. That function will include code that will be executed asynchronously. Well, usually it will include more than just one line. Usually it will include multiple lines. It will be a long function. And that function that we should pass over to the constructor function promise should include two parameters. The code inside the promise constructor function invoke this function that we pass over, and it pass over to this callback function two functions. As you can see, the function you pass over to promise should include two parameters, and you should expect that when your function will be invoked, the two parameters will be assigned with two functions. So you can invoke those functions. So what happens here is that your code in that specific function you pass over can either call the first function or the second function. If the first function is invoked, then it is a signal for success, meaning that the computation succeeded, the operation succeeded. If your code, for some reason, because something didn't work as expected, calls the second function, then it is an indication for a failure. So if you look at the promise constructor function and you look at the documentation, you will find an explanation about the state that every promise goes through. Every object you instantiate using the promise constructor function as a state, and that state is pending in the beginning. And then from pending, it can change either to fulfilled or rejected. It all depends on which of the two functions was invoked. So if the first function is invoked, then the state of the promise object changed from pending to fulfilled, success. If the second function is invoked, it means that the state of the promise object changed from pending to rejected. Now, on every promise object, we can invoke the then function. And when you invoke the then function, you are expected to pass over two functions. Now, if the promise object that represents an asynchronous execution of doing something, if that promise object changes its state from pending to fulfilled, meaning success, in that case, the first function that you pass over to then will be invoked. If the promise object on which you invoke the then function change its state from pending to rejected, in that case, the second function that you pass over to then will be invoked. So getting back to this code sample, over here you can see that the first function was invoked. So that means that the promise object on which then was invoked, the promise object that promised, the variable promise, all its reference, that promise object changed its state from pending to fulfilled, which means that the function, the first function we pass over to then, well, in this case, you can see that we pass over just one function, it will be invoked. Now, then itself also returns a promise object. So we can invoke then again and again, each time on another promise object. So whenever then is invoked, it returns a promise object on which we can call the then function one more time. Whenever you call then, you get a promise object on which you can again call then function. So this is exactly what happens over here. So let's, for instance, take this code sample. Let's create a simple demo. So let's improve the code. It can be const. So we first start with creating a promise object. Then on that promise object, we can invoke either we can invoke the then function. Let's change console.log. It will be simplified. And I will use Node.js for executing this code in my IDE. I don't want to go out to the web browser. So look, if I execute this code sample, as you can see it, you can take a look at the output. So we get this printed to the screen. you can see that each call to then is actually a call on a promise object. We could change the code into something else to make it simpler if you want const promise 2 equals promise 1 then. So instead of chaining calling to then, we'll get separated calls. So whenever you call then, you actually get a new promise object. So in this case, now we have this promise object, promise 1, let's call it. And because we have a call to resolve, it means that we have a success. It means that the promise object that was created over here, meaning promise 1, changed its state from pending to fulfilled. And because of that, the first function that we pass over to then over here that is called using promise 1 will be executed. So we get printed the promise executed computed then 1. Now, if we pass over two functions, and we can do so, so we have the first function, and then we have the second function. The promise executor failed. Now, if instead of calling resolve, I will call the second function, that will change the state of promise 1 from pending to rejected, and because of that, this function won't be executed. This is the function that will be executed. What is the problem? Promise 2. Oh, this should be promise 3. This should be promise 4. Okay, again. So now you can see according to the output that, okay, this output is generated. The promise executor completed then 1, we don't see that. We see instead this. As you can see. Now, so you can also see that you see that we have a failure, and that failure starts moving from, well, it is actually handled by this function. So we get the promise object, promise executor failed, printed. And this is the problem. This is not problem. Promise 2 should be. Okay, not promise 1. That's why we got this error. No, now it's okay. Now you can also see that we actually have several promise objects. The first promise object changed its state from pending to rejected, and that's why when calling then on that first promise object, the second function was invoked, not the first. However, from this moment on, from this promise on, the other promises succeeded, fulfilled, because the handling the failure took place using this second function. So this should be printed, and this should be printed as well, and everything is handled. Now, usually you will see a call to the then function with one function only, because usually we would like to have several functions to be invoked one after the other. Each function is executed asynchronously. So when you have a chain of operations that are executed asynchronously and you want to have them executed one after the other, you will usually chain those promises one after the other, as we did over here, or as I have just simplified over here. Now, if there is a problem and you don't handle that problem by passing over a second function to then, eventually that problem will arrive to the last promise. What happened to my ID? So, okay, I don't know what happened to the ID, but anyway, eventually, if none of the then functions you invoked one after the other handle the exception by having a second function we pass over to then, eventually that failure will arrive to the last promise, and we can, the last promise is the one that the last call to then returns, and we can call the catch function. The catch function is another function we can invoke on something happened here. I don't know why. What happened? Everything starts. Something strange happened. I forgot over here to do this. Okay. It's okay. Mhm. Promise 1, promise 2, then promise 3, promise 4. Um, okay, resolve. Now, if we change to reject and we don't have any handle for, we don't have handling for the exception or for the problem that happens, for the failure of the promise object over here that changed its state from pending to rejected, then you see that problem. But we can call on the last promise, we can call the catch method, and we can pass over a function to that catch method to print out to the screen problem, and that would be our handling for the exception. Just fix here. So we move from promise 1 to promise 2, from promise 2 to promise 3, and then calling catch at the end, meaning that we will handle any exception that took place that wasn't handled by one of the then functions. So now we can expect having problem printed to the screen. And that happens from here. Okay, let's get back to the slide because we are short in time. So we talked about the catch method. I didn't show you because we are short in time, but we can pass over data from one promise to the other. We can easily, for instance, over here, oh, it stacks again. We can easily pass over to the reject function or to resolve function data, and that data will be passed over to the first parameter of the function that is passed over to then, or to the function that is passed over to catch, one of the two. Something strange. We can pass over data. For instance, if we call resolve or reject, in both cases, we can pass something. Let's say we pass over the text computation result. That data will be passed over to the function that will be executed right after. In this case, the first function we pass over to then. So we can have a parameter, and then we can print the value of that parameter. As you can see, calling resolve means that the promise object, promise1, change its state from pending to fulfilled. That means that the first function we pass over to then that we call using promise1 will be executed. And whatever we pass over to resolve will be passed over to that function. So computation result as a text is printed over here. Now, if we call reject, then either that this data will be passed over to the second function that we pass over to then, and if we don't have such function, it will eventually be passed over to the catch, to the function we pass over to catch. So we pass over something like error 1, 2, 3. This will be passed over here to ERR, so we can print it like this. If I execute, you can see that this promise object, that promise1 holds its reference, change its state from pending to rejected, because we call the reject function, not the resolve function. And because of that, we can say that promise1 failed, it is rejected. And then we look about the next function that will be called. So given that we didn't pass over a second function to none of those then invocation, eventually we get over here, and this is the function that is invoked, and over here we take the data and do something with it. In this case, just print it to the screen. Okay, now what about async and await? So async is a keyword that when you attach it to a function, it means that this function is asynchronous, and it means that we can call the await keyword. You can call the await keyword only within the scope of a function that was marked as async function. Now, when you call the await keyword, it must be before an expression that its value is a promise object. And what await does, it simply pauses the execution and waits for that promise to finish and hopefully become fulfilled, meaning moving from pending to fulfilled. And when that happens, whatever is passed over to the resolve function, remember when you create a promise object, you need to pass over two functions. The first function is passed over to a parameter. Again, when you instantiate a new object using the promise constructor function, you need to pass over a function with two parameters. It can be an error function, it can be a simple function, whatever you want. In any case, that function with two parameters, or you can, in this case, I wrote only one, but you see there's only one parameter, but it should be two parameters. It means that if the first function that is passed over to the first parameter is invoked, then promise change its state from pending to fulfill, and whatever you pass over to that resolve function, the first function, this is what the await keyword will take out and return. So in this case, if you look at the code, this code, well, as I said before, we usually have two functions that are two parameters in that function we pass over to promise. We usually call them resolve and reject. Now, as you can see over here, F1 returns a promise object. You can see that. So because of that, we can specify, we can place the await keyword over here. And that means that when the execution arrives line 12, it stops and wait for that promise object to become fulfilled. When that happens, whatever is passed over to resolve, await will return back to us, and we will do something with it. So in this case, as you can see, here is just the definition of F1. Here is the definition of F2. So line 10, we execute it. You can see that line line 10 is printed. Then we have a definition for F1. Still, we don't see a call to F1. Then we have a print of line 20. And then there is the definition of F2. But still, we don't have a call to F2. Then we see line 29. And then we have a call to F2. When F2 is invoked, then we get F2 start. And then over here, we see a pause over here. Because in line 12, we simply wait for F1, for the promise object that F1 returns to finish its execution, to become fulfilled. Look, you see, we stop over here. Let's change the delay to be a bit more. So you can see that we are paused over here. F2 ends still wasn't printed. The result that await will extract out still wasn't printed. The result should be the text result. Here it is. Now it is printed. Or let's say result 1, 2, 3. So you can see that over here, the execution simply pause, wait for the promise object that F1 returns to change its state from pending to fulfill. And when that happens, then await will extract the data that was passed over to resolve, and that data will be assigned to result and will be printed, and then we get F2 ends, and that's it. But as you can see, anything else like this and this is printed. We don't wait for those asynchronous operations. Those asynchronous operations take place asynchronously. So line 33 was printed without waiting, of course, and the same with anything else. Okay, now one more thing. When you mark a function with the async keyword, that function becomes a function that returns a promise object. So you can, if you want, you can call catch method on that promise object that the asynchronous function that was marked with async returns. Okay, that's it. So what I've just tried was to simplify your understanding of the promise object and especially those topics. So back to you. Questions, please. And I will